This is David Hammaker, and we're looking at the PreLab for week 7 and EECE 225 in the lab. This week we're making this circuit, and here's the diagram that I made in falstad.com. And here's what's going on. We got our voltage source here, and what that is doing is it's getting that voltage is sent through a 50 ohm resistor, which is going to get really hot, and it's going to send heat over on this thermistor. And the way the thermistor is set up is basically a bridge here. We have two resistors here and two resistors here that create a differential voltage between them here and here. And what's great about this is when we look at our thermistor, right now it is 11K, which means it is cold, so it has a higher resistance. And what that is going to mean is that V minus here is going to be higher than V plus here. Now what's great is we have this op amp as a comparator. In lab we're using LT 1716. I'm using this model, the LM741 in LT Spice, but it works the same way. It looks to see if the voltage coming in on the top is smaller or bigger than the voltage on the other side here from V plus. And if V minus is bigger, as it is now, so we have, let's see, 3.99 versus 3.75, so V minus is bigger, so it's going to read this here and make V0 pretty low, right? Not well enough to set off this guy here, which allows current to go through. But as this resistor heats up, that heat is going to change the resistance of the thermistor. I'm going to edit it, take it down to, we'll say, 9K. So that brings this voltage here to, let me get it, there it is, 3.48, and this one here to 3.749, which means this voltage is now higher than that. Our comparator notices that, so it's going to switch on this component, which is going to allow current to flow through the fan here. And the fun thing about that is the fan is going to blow cool air on our thermistor. The thermistor is going to cool down, and that's going to change its resistance. As it cools down, it goes back up. And what that does is it switches our differential voltage, our comparator, then stops sending a voltage here, and this no longer has current flowing through it, and the fan turns off. So when it gets warm, the circuit detects it, fan turns on, cools it off, and when it cools off, the whole system shuts itself off until it heats up again.